Oh, no, I need to click the go live button, but previously it wasn't connected. Love that. All right. Great. Love to have additional steps that are not necessary. Anyway, the stream is fixed. Hello, welcome for folks that are just joining. So the paper reading group. So it's just me today, again, on this paper. I'm just going to tease it a little bit. Next week, we have a special guest on the reading group, which I am so excited about. And I'll try to remember to put the link to the paper today, rather. But basically, it is a paper looking at how well conversational AI systems happen when you start to perturb the conversation. So you just change things in the environment. How well do they, handle that? It's the basic idea. That's a coffee mug, not a mouse. But the paper we're reading this week is one that we started last week. It's from Tackle, which is the journal for the Association of Computational Linguistics, which is the professional scholastic organization, scholarly organization, I should say, for computational linguistics and NLP. And the Tackle papers are presented at ACL conferences, but the publication venue is the journal and not the conference, if that makes sense. They tend to be a bit longer. And we got started, and it looks like there's only a couple of papers here, but there are, in fact, authors. But there are, in fact, many authors. This is a very collaborative paper, and they're all out of Microsoft Semantic Machines, and Semantic Machines is a startup that was acquired by Microsoft. And someone mentioned yesterday in just like sort of a chat that they started at Berkeley. And I think I mentioned last week that something seemed a little Berkeley-ish about the way they were handling semantics, and I was right. That's it. That's the whole tangent. So the basic idea for this paper so far is that some of me is that tweets. Is that as you're having a conversation, so rather than having, let's say, specific slots that you are filling and then using those to plug into some text templates and then saying that and collecting those slots over time, you are generating this graph structure of the information that's been discussed in the conversation already. And for every turn, the assistant is using that graph structure to run queries against some sort of database. I think so far they've just sort of talked about how the graph structure is constructed and then return the utterance. So I believe the utterance is directly constructed from the graph structure. And also the information is queried when the person says something. I don't know. And I've been thinking about this paper a little bit, and we'll jump into it in a little bit more depth, but I feel like a potential bottleneck is if you're running multiple queries every time somebody says something, especially depending on like your setup and your optimization and whether stuff has been indexed or not, that could introduce quite a bit of latency. So hopefully they talk about that in the paper. So, sorry, let's go to the full text. And this is linked in the YouTube video description, and I'm just going to pop it in the Twitch chat right now so you can see it. Link to the... Okay. Let's jump back in. So we read the introduction and sort of the general idea of the paper. And the general idea is that you have this graph structure, which is sort of finding information that's relevant to the particular thing that you're doing, and then on the next turn, you keep the graph structure that you have so far, but you update it given whatever it is that the person wanted in their turn. And I believe we got all the way down to this aside, which is fantastic because this is what I am interested in. So I feel like hi Abdul, my intuition is that this is where we might run into, I think this is a really cool idea that might have really natural sounding dialogue, but my intuition is this is where we're going to sort of run into technical bottlenecks. Aside, response generation. Good morning, Faiza. Or Faiza? I'm sorry if I'm saying that wrong. this paper focuses on language understanding, mapping from a user's natural language utterance to a formal response. Formal here not meaning natural language, but fancier sounding, but a formal logical representation that is machine readable. In this case, the value of the outlined node returned by a program. And then, so in this graph structure here, tingle, tingle. I don't know if you can hear that. My dog's sort of trotting around happily. In this graph structure here, the information that you returned comes out of one of these nodes. These are nodes, these are edges. And I believe the nodes are functions and the edges are objects. Does that sound right? It's like TensorFlow that someone was mentioning, this sort of TensorFlow graph structure. Here we go. Dialogue systems must also perform language generation, mapping from this formal response to a natural language response. And at Rasa, we generally just do that by having utterances that you write. This dataset released with this paper includes output from a learned generation model that can describe the value computed at a previous turn, describe the structure of the computation that produced that value, and reference other nodes in the Dataflow graph via referring expressions. Okay, so one of the contributions of this paper is this data set that they have, which are task-based dialogue. Task-based dialogue is I want to do something in this conversation, not I'm just chatting to have like a fun conversation. And in their data set, they have output from a learned generation model that can describe the value computed at a previous turn, describe the structure of the computation that produced the value, and reference other nodes in the data flow graph. Okay, so this is a pretty hefty, sorry, I think I'm allergic to something. So this is a pretty hefty data structure that contains a lot of information, including sort of everything that's happened in the conversation up to the point. Support for structured computation conditional generation models is another advantage of data flow based dialogue state representation. So what they're saying here, to be structured, there are formal relationships between things in stuff. Between, in this case, different nodes and edges. There are like, A, there are nodes and edges, and B, they are linked to each other in this sort of structured formal way. And this is opposed to something like a language model where there isn't really formal structure. It's all just sort of, people will say unstructured. Language has inherent structure, which is why statistical models work, because it's picking up on an approximation of that structure, but it's not formally represented. Faiza says, can you speak about data cleaning in Rasa? I didn't understand last time. It's a little off topic. So basically, data cleaning is taking some data set that does not meet your specific needs for a project and changing it so that it does meet whatever your specific needs are. And for a basic Rasa assistant, if you're using a pre-trained model, you're probably not going to have much data cleaning. What you would do is just, you know, for the dialogue data, you just produce utterances that are similar to what you need and then annotate additional data. So data cleaning isn't really a big process of the Rasa assistant development process unless you are training a machine learning model and you have training data and the training data doesn't meet your requirements for training the specific model. So data cleaning is like a whole separate thing. And I actually have a course on Kaggle about data cleaning if you're interested, that doesn't talk a whole bunch about text, but does have sort of a lot of sort of the underlying philosophy of what's going on with data and talks about some of the things that can go wrong. So that might be a helpful resource. While a complete description of data flow-based language generation is beyond the scope of this paper, we briefly describe the components of the generation system relevant to understanding system presented here. So basically what they're saying is the language generation here comes from taking this structure and generating, you know, perhaps using a series of rules, natural language from it that represents this structured data. The generation model is invoked after the evaluation phrase. It conditions on a view of the graph rooted at the most recent return node. So I have a turn that queries this graph. It might add nodes, it might look at other ones, and then that is returned. And then that is used to construct a graph for the data generation. So things that are probably parents of that node or before it in this temporal flow would be my guess. As the generation model produces a natural language response, it extends the data flow graph. For example, if after the user query, what's the date of the next retreat, the agent responds, it starts on April 27 at 9 a.m. and runs for 8 hours, it will also extend the data flow graph to reflect the event's duration was mentioned. So the agent decided to mention duration, even though the person didn't ask for duration. They just asked for the date. I wonder how the assistant decided that adding duration was going to be useful here. The duration of the event is now part of the common ground in the conversation and available for future reference by either the agent or the user. The generation model is also important for agent initiative. Put an event on my calendar. What should it be called? So my guessing is that this agent is constructing a graph from like calendar event and is like, oh, there's no name, that node is empty, I need to get that information. As discussed in detail in section 5, questions of this kind can be generated in response to exceptions generated by underspecified user requests. Basically what I just said. In the accompanying dataset release, the agent's utterances are annotated with their data flow graphs as extended by the generation model. A little bit of coffee. In what case do we use normalization in Rasa? I would need more context for that. Because normalization can mean reference resolution. In a dialogue, entities that have been introduced once may be referred to again. In data flow dialogues, the entities available for reference are given as nodes in the data flow graph. So this is just sort of a general thing that's true of conversation, is as you have a discussion with people, you assume that they remember the things that you said to them, and that you both will refer back to them further on in the conversation. If that wasn't the case, imagine having a conversation where every turn you pretended it was your first turn talking to that person. So it would probably just be like, oh hey, oh hey, oh hey, oh hey, oh hey, back and forth, because there's no sort of like way to build on that and know that you've already greeted them. That makes sense? In data flow dialogues, the entities available for reference are given by the nodes in the data flow graph. Okay, so the nodes are entities, and just so nodes are these items, and then the arrows between them are called edges. Graph term. Entities are salient to conversation participants. I had a whole seminar in graduate school about salience. Basically, it means something that you pay attention to broadly. It's a really overloaded term. Entities are salient to conversation participants to different degrees, and their relative salience determines the way in which they may be referenced. Lapin and Leah, 1994. For example, it generally refers to the most salient non-human entity, while more specific expressions like the Friday meeting are needed to refer to accessible but less salient entities. So if I'm paying a lot of attention to something, how do you know how I've been paying attention to it? That's a good empirical question. I'm glad you asked it. When I say it, that's probably what I'm referring to. And if I want to refer to something that's a little bit less salient, I mean, there's also a recency bias, so things that you've referred to more recently are going to be more likely to be the thing that are referred to. Not all references to entities are overt. If the agent says you have a meeting tomorrow and the user responds what time, the agent must predict the implicit reference to a salient event. So that here the user is referring to the meeting, which is a node in this graph, and not the current time, I think is what they're meaning there. Yeah. Data flow pointers. Sorry, I have a lot of thoughts that are perhaps not particularly relevant, so I'm just going to move on. We have seen that refer is used to find reference for referring expressions. So refer is one of the operations that they've introduced for this graph structure and extending the graph structure. In general, these reference may be existing Dataflow nodes or new subgraphs for newly mentioned entities. We now give more detail about both cases. So just about subgraphs. So for an example, like here we have this start object that's pointing to a date time, and that date time has additional qualities like year, month, and day. So I believe that's what they mean by subgraph, is that year, month, and day related to a specific date time. We now give more detail about both cases. Imagine a dialogue in which the Dataflow graph contains the following fragment, which translates to a mention of Easter or answers when is Easter. So if the user mentions this graph will be constructed. If the user asks when is Easter, then this is the graph that the assistant would construct to answer that question. Suppose the user subsequently mentions the day after that. We wish to produce this computation. So for the given date time, we're going to add 1 day. In our framework, this is accomplished by mapping the day after that to refer days 1. The corresponding graph is not quite the one shown above, but it evaluates to the same value. So here they're specifying the thing they're adding is a date time, and the thing that they're looking for is also a date time. And then this reference operation is what appends this substructure to the graph. This shows how the refer call is reified as a node in the Dataflow graph. Its result is the salient find date time node from the previous turn, whose own result, a specific date time, now serves as the value of refer. How are you measuring saliency? What makes it salient? Is it just the thing that was returned last turn? In that case, I would not call it salient. I would call it the most recent. Just because there's additional... Yeah, like I mentioned, salience is just an extremely overloaded term, so it means a lot of different things. Feza says, if I'm using just the Rasa pipeline, then I don't need to do data cleaning because the pipeline provided already cleans the data. Yeah, more or less. Usually data cleaning is something you do before modeling or before data analysis. And like the Rasa framework builds models for you, so you shouldn't have to deal with it in like the simplest use case. As soon as things start to get a little bit more interesting, or you're starting to add your own pipeline components, then it becomes more relevant. If the result is the salient find date time node from the previous turn, whose own result, a specific date time, now serves as the value of refer. We show both result edges here. Evaluating plus adds a day to this old date time to get the result of plus a new date time. To enable Dataflow graph manipulation when with referring expressions, all that is required is an implementation of refer that can produce approximate pointers for both simple references, that, and complex ones, the first meeting. So they're saying that all you need to do to use referring expressions is make referring expressions? Okay. Like, they're not wrong. A call to refer is essentially a query that retrieves a node from the dialogue history, using a salience model discussed below. Okay, so they introduced this term of salience and did not discuss how they were defining it, and they do have a definition of it. Refer takes an optional argument, a constraint on the returned node. Indeed, the proper translation of that in the context the day after that would be refer constraint date time. So this is just like, hey, I want this to be a particular thing. In this case, a date time entity, I think they called these. Constraints are predicates built from Boolean connectives and the constructions illustrated below. Rohit says, is there a way to connect a Rasa bot with Microsoft Teams? I don't know. I'm not super familiar with Teams, so I think that would be sort of the limiting factor, but if they have an API, then yeah, absolutely. So the way you would do that is that you would have, well, okay, I don't know what you mean by connect. If you mean, can you have like, I don't know if Microsoft Teams is like a chat function? then I would look for like a Microsoft Teams connector. But if you mean I want to be able to make queries against information in Microsoft Teams using some sort of API, then also yes. I haven't seen anybody do it. That doesn't mean that A, they haven't done it, or B, it is not possible. Okay. Type constraints. The meeting maps to the call refer, where the constraint matches all the nodes with values of type event. Okay, so here we are just looking for, everything that matches this type. Property constraints. Assuming a structured event type with a date property and a date type with a weekday property, the Thursday meeting maps to this. Nested recall. Okay, so here, okay, so there are events and there are properties, and you can say that you need to match one or the other. Role constraints specify a keyword and matches nodes that are used as keyword arguments with that keyword. For example, the month maps to refer, role constraint month, and resolves to the constant node APR in the dialogues in section 2, since that node was used as a named argument month equals April. We further allow keyword paths that select arguments of arguments, thus in the previous bullet would satisfy refer, role constraint, day, weekday. Okay. Ugh. So I am noticing that there are a lot of things that nodes can be, and perhaps this is more clear if you've done more work in this sort of data flow space, and these are standard terms, but there are a lot of terms that are being used here without being defined super in depth. So I think what would be helpful for me, just as a reference reading this paper, would be like a table with examples where they're like, this is what a type is, this is what a property is, this is what a role is. I don't think I have that. Let me check. So we're right above that big section. Flow results, data set statistics, manual classification, multi-was, related work, conclusions. Oh, the related work at the end. I hate that. Drives me nuts. Yeah, no, I don't see no helpful little table. So if this is like the normal terms that people always use to refer to these things, then I think that's fine. But as someone who just sort of has, I guess the most relevant work that I'm familiar with would be like parsing stuff. It would be helpful to have a little bit more detail. I don't know. Because I still need to do data cleaning. It depends. So you would need to do data cleaning whenever you have a data set and you need to use it for something and it's not in the right form to use it for that thing. That's all that data cleaning means. So, I mean, there are many situations where you could be in that position, and I cannot tell you all of them right now. Does that make sense? It's like it would be like, when am I going to need to write an if statement? Like, I don't know. There's lots of places you might need to write an if statement. I can't just like list all of them, if that makes sense. I can tell you what an if statement does, but I can't like prepare you for all the places you're going to need them. I hope that makes sense. It's a very general term. To interpret a natural language referring expression, the program prediction model only needs to translate it into a contextually appropriate constraint C. Refer C is then evaluated using a separate salience retrieval model that returns an appropriate node. Okay, so their salience is like a measure that they're using to predict which node is going to be the most relevant to the particular turn that they're in. The following expression shows referring expressions in action. What happened this morning? Find event specification, start, today, morning. So this is the query. You have a planning meeting at 9 a.m. What do I have after that? Find event specification, start after the end of the reference constraint event. So because this is the full conversation, it's just going to look for any previous event, and there's only one. Your birthday lunch is at 12:30 p.m. How many people are coming to the 9 a.m. meeting? Length attendees refer constraint event start 9 a.m. So here they're constraining the event to be one that starts at 9 a.m. 9 people will be at the 5 a.m. at the planning meeting. So my question here is, what if they didn't say 9 a.m.? So your birthday lunch is at 12:30. How many people are coming to the meeting? Would that refer to the most recent event, which would be this birthday lunch, or is that going to refer to the meeting, this other event? Because this event does not have, so I guess that would be like the keyword thing where they looked up meeting. But how would they know they need to look it up if they try this like constraint event and they already find an event that matches that, right? So yeah, I don't know that I'd say 9 a.m. in this situation if it were me. Here, the 9 a.m. meeting refers to the one that is salient from the first response, not an arbitrary one. Okay. Salience retrieval model. I think this will answer a lot of my questions. Hi, Ismail. The salience retrieval model returns the most salient node satisfying the underlying constraint. So this would be how they would disambiguate between the meeting and the birthday lunch event. Our Dataflow framework is agnostic to the implementation of this model. Okay. So they're saying you figure it out. You could use anything. A sophisticated model could select nodes via a machine learning scoring function. In the experiments in this paper, however, we rank nodes using a hard-coded heuristic. Okay, so they're saying, hey, you could machine learn this. We're using rules. Here's the rules. The heuristic chooses the root node R of the previous user utterance if it satisfies this constraint. Okay, so in this example, we would get, if we didn't specify 9 a.m., they would tell you how many people came to the lunch and not how many people were going to be at the meeting. More generally, the heuristic prefers nodes to the extent that they can be reached from R in a small number of steps, where a step may move from a node to one of its input nodes, from an evaluated node to its result node, or from the root of an utterance to the root of an adjacent utterance. So if I have, so it's going to prioritize things that are close to the most recent node. If no satisfying node is found in the past several utterances, the heuristic falls back to generating code, see footnote 2, that will search harder for a satisfying salient entity, perhaps by querying a database. Okay, gotcha. So also these heuristics are getting you out of running full queries every time, and instead are just searching the subgraphs and then extending the subgraphs where necessary, which I can only assume they're also doing by running queries, but I could be wrong about that. For example, our earlier constraint event, start 9 a.m., may return the expression find event specification, start 8 a.m. 9, if no 9 a.m. meeting has been mentioned recently, and constraint person name Adam may return find person spec name Adam if no Adam has been mentioned. So these are the queries that would be generated if they haven't been referred to in the conversation previously. Revision. Beyond referring to the previously mentioned entities, nodes, task-oriented dialogues frequently refer to previously executed computations, subgraphs. This is one of the major advantages of representing the dialogue state as a data flow graph of computations, and not just a set of potentially salient entities. Let's say I develop a bot with Rasa, and I'm asked how I did data cleaning. Am I going to write that I used the Rasa pipeline to clean my data? I mean, if you didn't do data cleaning, I would just say we didn't have to do data cleaning. Because so the way that you generally train a Rasa assistant is that you provide example utterances, and because you are generating a small data set for your specific use case, you can generate it in the format that you need it, so it doesn't need to be. Hopefully that makes sense. All right. What time on Tuesday is my planning meeting? It generates this whole thing. You meet with Grace at noon. Sorry, I meant all hands. Your all hands meeting is at 2:30. The second user utterance, I feel like there should be one of these queries here. The second user utterance asks for the computation from the first user utterance to be repeated, but with all hands in place of planning. The expected result is still a time, even though the second utterance makes no mention of time. In the Dataflow framework, we invoke a revise operator to construct the revise computation. Okay, so here's the query, revise root location, role constraint output. So they're using the output of the previous turn using the location constraint. Okay, oh, so they're looking for a node that has string in it, and then they're revising it with all hands instead of planning. Again, the content of the program closely reflects that of the corresponding utterance. The revise operator takes 3 arguments: root lock, a constraint to find the top level node of the original computation; old lock, a constraint on the node to replace within the original computation; and new, a new graph fragment to substitute there. The revise node evaluates the root of a modified copy of the original computation. So, like strings in Python, you cannot, you have to copy to change. Immutable, that's the word I'm looking for. In which new now fills the role at the old location. Normally, root lock is a role constraint output, which selects a node returned by a previous user utterance, thus we revise the original request. Revision is non-destructive. No part of the dialogue history is lost to the entities computed by the original target, and its ancestors remain available for later reference. However, the copy shares nodes with the original computation where possible, to avoid introducing unnecessary duplicate nodes that would have been considered by refer. Okay, so when they mean copy, when they say copy here, they mean extend, because they're reusing nodes. I'm sure they do mean copy, but I would say extend just to make it a little bit clearer in non-technical language. Rasa says, so in case of writing NLU domain and stories is a clean data that I don't need to clean. Am I there yet for understanding? Yeah, I'd say so. And because we're using pre-trained models, you don't need to produce a lot of. And we suggest that you are producing examples for like as little time as possible, and then you put it in front of folks, and then you get their their responses, and then use those ASAP. That's the Rasa way. So hopefully that's clear. Blah 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 blah. For the example dialogue at the beginning of this section, the first term produces the light gray nodes below, these ones. The second term adds the darker gray nodes, which specify the desired revision. So the nodes that are being changed are copied, but we still share nodes with the first graph construction, I guess. The graph for the previous utterance. Finally, evaluating the revised node selects the salient locations that match the root lock and old lock constraints indicated in the above drawing by temporary dotted lines, and constructs the revised subgraph, the new start node below and its ancestors. The result of evaluation, dashed arrow below, is the result of the revised subgraph. That makes sense. Finally, evaluating these new nodes as well will establish that the value of the top level revise is the start time of the all hands meeting on Tuesday. In the following example, the second utterance asks to replace a date specification. However, the utterance appears in a context where the relevant date time spec valued node to be replaced is an argument which has basically not been provided. When is lunch? It's at 1 p.m. What about tomorrow? So here we're replacing date time, but there is no date time here in this first graph or first query. The revision replaces the missing start argument to the previous event spec, whose absence has resulted in some default behavior, with an explicit argument, the datetime spec returned by tomorrow. To achieve this, when the salience retrieval model is run with an old lock constraint, it must be able to return missing arguments that satisfy that constraint. Missing arguments are implicitly present, with a special value missing of the appropriate type. In practice, they are created on demand. Evaluating the revised nodes results in the new revised subgraph pointed to by the dashed arrows, which can then be evaluated. So if additional information is needed so when you construct your graph, if you have required information that is not there, the nodes are constructed with missing values and sensible defaults, it sounds like. And then those are evaluated, and if they are changed, then the missing value is changed into not. Yes, I think. Coffee. So they are describing what the system should do. And they're saying they do it with like rule-based heuristics. That's a little redundant. And you could use machine learning for it, but they're not sort of providing an option for that. Let's finish this example, and then I got some thoughts. Relatedly, a user utterance sometimes modifies a previously mentioned constraint, such as event spec. To prevent this and more, we allow a more flexible version of revise to non-destructively transform the subgraph at old lock by applying a function rather than substituting a given subgraph new. Such functions are similar to rewrite rules in a term rewriting system, CLOP 1990, where the old lock argument supplying the condition. Our dataset makes heavy use of revise constraint calls, which modify a constraint as directed, while weakening it if necessary so that it remains satisfiable. For example, if a 3 o'clock to 3:30 meeting is on screen and the user says make it 45 minutes or make it longer, the agent can no longer preserve the previous constraint starts at 3 and ends at 3:30. One must be dropped. Well, the examples in the section involve us. Okay, so this is what happens if by some action the user takes, the graph is no longer accurate. While the examples in this section involve a single update, real-world dialogues can involve single user requests built up over as many as 5 turns with unrelated intervening discussion. I feel like 5 turns is a little low. Revisions of revisions or of constraints on reference are also seamlessly handled. Well, that's a claim. Revise can take another revise or a refer node as its target, leading to a longer change of result edges dashed line to follow. Coordinations of interactions among these many long-range dependencies remain a challenge even for modern attentional architectures like transformers. Bordas et al. 2016. Well, this is before the transformers paper, so it's probably bidirectional LSTMs with attention given that date. With revise, all the needed information is in one place. As experiments will show, this is crucial for good performance in more challenging dialogue. So, I think the key benefits of this system from like a user endpoint is if you are asking for things that have a lot of context and you're doing it over a fairly short dialogue. Although they're saying this works pretty well with longer and more complex dialogues as well. So things that I'm thinking about is as this graph gets, because the graph is just sort of like appended to, right? It just gets bigger and bigger over time. Or is copied and copied more and more over time. If I have a very long-running conversation, or let's say that I am a customer assistant and I am working with a customer, and then there's a human handoff, and then back to a bot handoff, and this graph has gotten really, really big and unwieldy, and the person has a lot of questions, and it's a very complex case. I wonder at what point these operations start to take enough time that it is really noticeable to the user, particularly if there are a lot of queries being run. And again, there are things you can do to make queries run faster, but sometimes they're just slow. And that's also, you know, if this is happening to extend the graph every turn. Yeah. I feel like that could be a potential bottleneck. Also, there's definitely a sweet spot in how much information you should give. So in this example dialogue here, where the person's like, so what about the 9 a.m. meeting? If I, like, to me, this sounds a little unnatural. I probably wouldn't specify the time of the meeting. But given this constraint that it's just looking for an event, it would return information about the lunch, right? So it looks like there's a pretty strong recency bias in this particular approach, or at least the way that they're constructing salience and the way that they've discussed this in the paper, which I don't know is inherently a super bad thing, but I think it could be really frustrating if I'm trying to backtrack, like, let's say I want to see a movie, I'm asking a bunch of questions about a movie, I decide I don't want to see that movie, and so I go back and I try to find out information about another movie. I think those first couple turns when I'm trying to like change the topic to another movie that require a much longer distance dependency, I'm going to need longer distance in terms of the conversation structure. I'm going to need to specify a lot of information for this approach to be kind of seamless, right? Yeah. But I guess the big benefit is that it's very straightforward to ask for additional information and to know what information is missing. So that's definitely a benefit of this. And I do like that it is structured, and particularly if you're doing language generation, I would feel very comfortable generating answers with this particular approach, because you know what you're going to get, right? You're going to get a natural language representation of this, you know, structured formal data structure. Structure. I can say that a couple more times. Jacob says, where can I find the article? The link is in the YouTube description. So if you just like pop it open and scroll down a bit, you should see it. And I don't know what will happen if I leave this page. The new YouTube streaming stuff is... So, yeah. Yep. Oh, no worries. Very reasonable to ask for a link to the paper. Yeah, also at some point... Because the thing about, like, a transformer-based attention model and having, like, the whole history of the conversation... I don't know which is... Actually, this may be more data efficient. Yeah, it might be less memory intensive. There are like a lot of connections though. And it's like a big hierarchical structure. So if you really needed to like go all the way through the hierarchy, especially with like a very big big complex data set, I don't know. It's interesting. It's definitely different than the way that we do things at Rasa, and pulls together a lot of sort of ideas that are out there. And I don't think it's bad. I just don't know how easy it would be to implement. I guess that's like that's what the company does, right? They do the implementation for you, and then you use their product. I don't know that much about semantic machines. All right. Recovery. I think this is gonna answer a lot of my sort of questions that I have about how good it work in a more natural dialogue. Some users make requests that can be fulfilled only with the help of follow-up exchanges, if at all. Requests might be incomplete. Book a meeting for me. When should the meeting start? So this is similar to forms in Rasa. If you need to collect a bunch of information to do an action, someone could trigger the action, and you're like, oh, we need to just start a form in order to get the pieces of information. Referentially ambiguous. Who is coming to the planning meeting? Susan Chu and Susan Brown. What is Susan's email? Or have no identifiable referent, a presupposition failure. When is my first meeting on February 30th? So the presupposition is that there is any meeting on February 30th, and in this case, there are no meetings on February 30th. Our solution is to treat such discourse failures as exceptions. In principle, they are no different from other real-world obstacles to fulfilling users' requests, server errors, declined credit cards, and other business logic. To be useful, a dialogue model must have some way to recover from all of these exceptions. I lost my place. Describing the problem to the user and guiding the dialogue past it. Our dialogue manager consists mainly of an exception recovery mechanism. This contrasts with traditional slot filling systems, where a scripted policy determines which questions to ask the user and in which order. And ours, Rasa, is a little bit different than that, but it's the same idea, but instead of having a sort of a rule that says we do X, we do Y, we pick among the potential things that we could do using, you know, whatever it is that you're using for your dialogue policy, like TED, for example. Scripted policies are straightforward, but cannot handle novel compositional utterances. Does that mean an utterance that does multiple things, or does that mean utterances in an order that they haven't seen before? Contextual semantic parsers treat compositionality, but provide no dialogue management at all. Okay, so I think that means an utterance that has multiple pieces of information in it. Our Dataflow-based approach allows the user to express complex compositional intents, but also allows the agent to reclaim the initiative when it is unable to make progress. That is one thing. This approach does not have intents. This approach has generates a structured representation of what the user needs, rather than mapping it to one of a class of predefined things. Specifically, the agent can elicit interactive repairs of the problematic user plan. The user communicates such repairs through the reference and revision mechanisms described in preceding sections. So the agent will ask questions when it's not clear what it should do next, and will disambiguate, which I do like. I think that's a definite approach of this system. Exceptions in execution. In the Dataflow graph framework, failure to interpret a user utterance is signaled by exceptions, which occur during evaluation. The simplest exceptions result from errors in function calls and constructors. So there's nothing on February 30th. Oh, right. Sorry. The presupposition is that February 30th exists. February 30th does not exist. I was wrong about what the presupposition was. So I can't find this date. Evaluation of the Dataflow graph specified by this program cannot be completed. The datetime spec constructor generates an exception, and descendants of that node remain unevaluated. So looking for this datetime, there's nothing there. Exception. An exception is essentially just a special result, possibly a structured value returned by evaluation. It appears in the Dataflow graph, so the agent can condition on it when predicting programs in future turns. When an exception occurs, the generation model, section 2, is invoked on the exceptional node. I probably would have said the node which produced the exception, but you do you. This can be used to produce prompts like, there is no 30th of February. Did you mean some other date? At this point, recovering from the exception looks like any other revision step. The user supplies a new value, and the agent simply needs to patch it to the right location in the Dataflow graph. There are several answers the user could make indicating repairs at different locations. I meant February 28th, I meant March. The fact that exception recovery looks like any other turn-level prediction is another key advantage of Dataflow-based state representations. That is true, because instead, if you had sort of a, fallback policy that was triggered here, it would probably be like, I'm sorry, I don't know what you mean, instead of like, specifically, this date does not exist. So I think in terms of handling things that are, slightly unhandleable, this definitely has the benefit. This particular approach has a benefit. In the above examples, the user specified a revision that would enable them to continue, but they also would have been free to try another utterance. List all my meetings in February, or to change goals altogether. Never mind, let's schedule a vacation. Because of its flexibility, our exception handling mechanism is suitable for many situations that have not traditionally been regarded as exceptions. For an example, an interactive slot-filling workflow, forms, in Rasa, can be achieved via a sequence of underspecified constructors, each triggering an exception and eliciting a revision from the user. So here, they mean to create exceptions. Create a meeting, what should be called, planning meeting, when should it start? The agent predicted that the user intended to revise the missing name because an exception involving the name path appeared in the dialogue history on the previous turn. Recovery behaviors are enabled by the phase separation between constructing the Dataflow graph, which is the job of program synthesis from natural language, and evaluating its nodes. The Dataflow graph always contains a record of the user's current goal, even when the goal could not be successfully evaluated. This goal persists across turns and remains accessible to reference, and thus can be interactively refined and clarified over the same metacomputation operations as user-initiated revision. So basically what they're saying is looking up the information that we need and developing the graph are two separate operations. So if we have a problem with one, we still maintain the other. Exception handling influences the course of the dialogue without requiring a traditional handwritten or learned dialogue policy that reasons about full dialogue states. Our policy only needs to generate language, recall section 2, that reacts appropriately to any exception or exceptions in the evaluation of the most recent utterances program, just as it reacts to the ordinary return value in the case where evaluation succeeds. So I think I'm going to call it here. So they have a whole big section of their data set, which is one of the what's the word? Contributions. One of the main contributions of this paper. And it's available, and they have an annotated data set. So they've done the, that's not what I wanted. Very good. And they have done some annotation as well. So they do all this thing. Okay, so this is an example. Other things that they do, they did some experiments and evaluations. We can just, oh, y'all can't see that. Sorry, it opens in a pop-up. Well, you'll never know. And then lots of places, and then the related work at the bottom. And then conclusions. So yeah, things I'm thinking about. This approach is going to work well. So it is specifically for task-oriented dialogue. This is not going to work super well for like a chit-chat system, or just maybe an art project where you just want to generate information or generate language and react to language in a way that doesn't relate to an underlying data structure that you already have access to and has already been defined. So it could work for like a game where you have like an inventory and you're managing your inventory. There are games that are, that's the whole thing. Yeah. It's a very different way of approaching dialogue systems, for sure. So the sort of the more common approach is that you have intents, and every turn you classify into intents, and then you do natural or named entity recognition to pull out the specific entities that are important. And then you have a dialogue policy where you decide what to do next. This approach has, I think, a lot more overhead in terms of the amount of work that it takes to construct this dialogue, and there's a lot of operations that happen. I don't know how fast this is gonna be. In general, constructing hierarchical models of language, so things like parsing, tend to take, you know, a little bit. So it could potentially be a little bit slower than something that's just like running a classifier super quick and then popping out the next thing. I don't know that that's the case. That's just sort of my intuition saying that. I like the error recovery. I think that's very natural. I think making this work well in practice is really going to depend on that saliency measure that they sort of brush over a little bit. I think defaulting to the most recent is not always going to be a great option in task-based dialogue, because people do want to backtrack and explore other things. I don't know what I would do instead of that, though. I'd probably use a transformer-based model to pick the previous event that's most relevant, based on some training corpus. And by some training corpus, I mean specifically the annotated training corpus that they present in this paper. And the big benefit of transformers over their sort of puristic model that just picks the most recent thing, it's not a very big search space compared to just like an enormous body of natural text, because it is structured. Transformers don't tend to work as well with hierarchical models as LSTMs in particular. So they might not work great in this instance. I'm trying to remember the reference for that. I gave a talk about it at the Advanced Topics on Machine Learning meetup here in Seattle. So I think it's online somewhere. You can find it. Yeah. Yeah. But the big benefit of transformers is that you can handle those long distance dependencies between conversation terms. I don't know. It's interesting. I would want to poke around with a system that uses this and basically try to break it. I don't know if there are any available. Let's see. Semantic machine. Semantic machines, all about it. Downloads, dataset, and the code and the data. So I'll pop this up. So I just Googled semantic machines. So this is their dataset. This is the link to their code. Can I use the system though? No, I don't think I can. Okay. Yeah, and they do have a big system evaluation, but that might be something to look at in the future. I don't know. It's interesting. I'm interested to see where they go and what more they do, and I think if this genuinely excuse me, I think if this genuinely works better for the majority of dialogue cases, people will start using it in more places, even though I think it is going to be a little bit more it's a little bit more involved, right? It's more of a it's not really more it's less of a machine learning engineering task and more of sort of a traditional software engineering well, I don't know, it's not really that even. It's old school, right? It uses a lot of older techniques that I think would work pretty well. And I think if you didn't have a large training data set, like they offer a training data set here, but I think if you didn't have a very big one, this might be a good option. Again, especially if you have this underlying data structure that you know that people, or database that you know that people are going to want to interact with. Yeah, I don't know. Interesting paper. I'm happy they shared their work, and I'm interested to see what they do in the future as well. I really wish I could use this assistant. Because I don't know that the code has like the full. I don't know that the code has the full everything you'd need to write an assistant, basically. So yeah. All right. Well, thank you for joining me today for the paper reading group. Next week we're gonna get started on a new paper, and I'll post about that on the YouTube community tab. And tomorrow I will be back with live coding, and we're going to be looking into starting to update the dialogue bot assistant for Rasa 2.0. So for those of you that haven't heard yet, we're working on the stable release of Rasa 2.0. We're going to sort of like switch. 1.0 will still be like available and supported, but lots of quality of life, and like new things in 2.0. So yeah, we're going to be working on migrating our project. All right. Thanks so much for joining me today. I hope you found this interesting. I think it's definitely an interesting paper. And always great to have more dialogue data sets. A little bit of they're very expensive to build. So it's great to have more resources available, and cheers to this team for making theirs available. And I will see you tomorrow for live coding. I'll talk to you then.